Hi, my name's Natalie McClutchie and you are watching McClutchie Maths. We are currently working through our 2025 update of the Queensland syllabus in Australia and how to write a mathematical report. We call it a problem-solving modelling task, or a PSMT. And this is a video on statements of observations and assumptions. There'll be two videos altogether on observations and assumptions. In this one, we'll show you how to write a statement, and in the next one, we'll show you how to justify it. Now, before we continue on, here are some ways that you can engage further with me here at the channel. Firstly, you could consider liking and subscribing and hit the notifications bell so you'll always know when the next video is available. There's something now called Super Thanks. It's a little heart that you can see with the word thanks next to it. If you click on that, you can donate $2 or more to the YouTube channel through your PayPal account, just to say thank you for the hard work we're putting in here and the resources that we're creating for you. You could also follow on social media. We're on Facebook and Instagram. And why not tell us in the comments? Why not even consider sharing the video with a friend or a teacher, or putting it on your Class 1 note? Right, let's get straight into it. In this video, I'm going to talk about what the new instrument-specific marking guide, the ISMG, looks like from 2025. I'm going to talk about the difference between observations and assumptions and how to lay them out in your assignment. Do stay tuned for our next video, which is also about how to make sure those observations and assumptions are justified. So let's have a quick look at the new ISMG. Here is where our focus is today, on these two particular points here: justified statements of important assumptions, justified statements of important observations. There are a few little changes this time around. We've got this word justified instead of documented. It virtually means the same thing, but this is more language that we're used to seeing right across all of our syllabuses. We're used to being asked to justify. It's a cognitive verb, whereas documentation had a bit of confusion around it. So the QCAA has updated the language to make it more student-friendly. We've also got this word important, and notice that this differs from down here where it's relevant. So we're going to be discussing the difference between importance and relevance. Okay, and over here you'll notice that I've circled this here. It's plural. That means you need a minimum of 2 each. So if you've only got one observation and one assumption, you are not going to hit up here, whereas this one here is not plural, it's singular. So if they can only find evidence of one in your assignment, you're automatically going to drop down to this box, and make sure you've got at least 2. Let's talk about what an assumption is. Well, it's defined as data or information required to solve a mathematical problem or develop a mathematical model. So if we think about that, it's important information that makes it an important part of the task. Okay, now for example, if you are going to be using Pythagoras' theorem with right-angled triangles in your assignment, you know that in a real-life context, the ground and the vertical object have to be at perfect right angles to one another in order to apply that formula, because c squared equals a squared plus b squared, Pythagoras' theorem, counts on the fact that the triangle is a right angle. So this is mathematical things you know about this problem, that an observation would be that the formula requires a right angle triangle. Therefore, you'd be expecting a perfectly vertical wall and a perfectly horizontal ground. That could be a good observation there. You might also know, for example, that friction and air resistance affect the motion of an object, which is going to affect your ability to accurately develop a model for velocity or acceleration. This would be a kind of assignment that you'd be expecting to see all the way up in senior for methods. So when you know that there are other forces at play that affect the motion of a vehicle, then you would discuss that as an observation. You can also make observations about your data set. For example, you might observe that there's an outlier in a graph that you've done. You might observe some correlation between two variables. You might observe that there's an upward trend. So once again, observations can be about things that you have created as part of solving the problem. It can also be relevant knowledge about the context of the problem as well. So this is where at the very top of your task sheet, your teacher will have given you a real life context to apply this modelling problem to. So you might be doing an assignment, for example, on bone lengths. This seems to be a very popular topic for PSMTs in the senior years. You might be looking at teenager measurements, and you need to think then about what you know about teenagers and what you know about bones. You know teenagers aren't finished growing. That's an observation that's going to affect your results. You might also know that bone length can be affected by health and nutrition, the ethnicity of the person, DNA, genetics. So knowing those things about the context gives you observations that there will be other factors that are going to affect your results. Remember, observations have to be relevant to the task and they have to be important. They have to affect your results. It's not enough to just say things like Excel is really good for doing formulas and it's very accurate. It's not about the mathematical knowledge. It's not about the context. It's not about the solution, okay? It's just one of your tools that you're using. It's not relevant to the task. It's not important to the task. Yes, it is accurate and it does help you out to solve the problem, but it's not the core of what you're doing. So it can also be information that you don't know. So these are things that are relevant to solving the problem. For example, if you're doing an assignment about celebrity face measurements, maybe you're measuring the mouth width of celebrities, the face width, the face height, the size of their eyes, how far apart their eyes are. Now, if you don't know if the person has had plastic surgery, now it's pretty obvious that this lady has, but if you don't know if the person is naturally that beautiful or if they've had plastic surgery, well, then that is an observation that plastic surgery can affect the results. So that might be something you don't know if the celebrities in your sample have had plastic surgery. It's going to affect your accuracy. It's going to affect your ability to rely on the model you're creating. That's a valid observation. Another example here is if your teacher has given you a data set. You don't know the source of that data, how it was collected, if it was collected accurately or consistently. You don't know if the measurements taken were done by an amateur or with faulty equipment. That's something you can observe, it is uncertain how the data was collected and measured and if every step was taken to ensure that it was collected consistently and accurately, which is going to make it difficult for you to rely on the outcoming results. Observations can also be called confounding and control variables. We've talked about variables in a previous video. Go and watch that if you're not sure what control variables are. But we know from science that if we're conducting an experiment in science that we only want to measure the effect of one variable on another. But sometimes there are other variables that we need to keep the same so that we aren't affecting things too much. Now, an example of this might be if you've built a balloon-powered car and you want to see, based on the size or the circumference of your balloon, how far the car will travel. And each time you change the circumference and measure that distance of how far that car's traveling. Now, if you were to put it on different surfaces each time, that would be a control variable. You want to keep it on the same smooth surface so that the impact of friction is not different from experiment to experiment. You might not want to put that vehicle outside for some experiments and inside for others because air resistance or wind might affect the vehicle outside. That would be a control variable that you need to keep the same each time. So observations could be that there are certain variables that you're going to be observing should be kept the same in order to get accurate results. Now, confounding variables are a little bit different. Confounding variables are variables that might affect the results and be something that's outside the scope of things that you can control. Now, an example of this might be you might be comparing ice cream sales to bikini sales. And you might observe that there's a strong correlation between ice cream sales and the bikini sales. Now, you wouldn't be saying that as the number of ice creams increases, then if I'm a store owner of a bikini shop, I can assume that I'm going to be selling more bikinis because look at all those people out there eating ice creams. In fact, the opposite could happen. The more ice cream you eat, perhaps you might not want to wear a bikini in public anymore. Okay, so that would be considered a confounding variable. The thing that is causing both of those variables to increase at the same time is the weather, the temperature. It's not something you're even measuring, but it's having an effect on both those variables. So these are things you might consider or observe in your initial observations, and they are definitely relevant and important to the task. There are also many factors that do change results, so identifying those factors is an observation. Now, let's say you've come up with 5 different possible control variables. If you're wanting to get credit for 5 valid observations, don't write it all as one observation. Split them out. So, for example, if I'm comparing that example I gave before, 2 bone lengths to one another, and I know there's actually something outside bone lengths that is affecting that growth, diet, DNA, ethnicity, things like that, rather than listing that as one variable, one observation, break it into 3 separate observations. So it is observed that ethnicity can affect the length of your bones. And then you might give an example. For example, people in this country are typically shorter than people in this country. Add a source and you've got a justified observation. Then you might make your next dot point. It is observed that nutrition can affect bone growth, and people with a better diet or a higher protein diet would typically grow better in their teenage formative years. Give a quote. Now you've got a justified observation. Now you've got two observations. If you combine them as one, as a list, and I'll give you an example of that, it is observed that there can be other factors that might affect bone length, including ethnicity and nutrition. Well, now you've got one observation instead of two. So break them apart, give a source and an explanation for both of those. You've got yourself two bonus observations. Okay, here's some more tips on how to write those observations. Firstly, before you start writing, think deeply about your topic. What do you know about the topic and what don't you know about the topic? This is a good time to have some conversations with the adults in your life to get a little bit more information about your context. So don't be afraid to do a little bit of a deep dive on the internet into your context. So if it was a context about celebrity face measurements, do a bit of a deep dive. What percentage of celebrities have had plastic surgery? If it's about bones, do a bit of a deep dive. Get yourself a source. That's not going to be the focus of your assignment though. So don't get hung up on researching forever and ever and ever and doing doom scrolling all through the night, trying to work out everything you need to know about this subject. You're not expected to be an expert about the context. You're supposed to be an expert on the mathematical knowledge that you're demonstrating with that context in mind. So what I would suggest you do is just do a little bit of research, ask some questions of people. It'll help you come up with some observations about those control and confounding variables. Talk to those adults. They do tend to know a lot more than we give them credit for. Mums and dads, grandmas, grandpas, aunties, uncles, neighbours, people with a bit of life experience tend to know a little bit more about stuff. So ask them, what would they write as an observation? Some other things to think about is your data set. For example, think about who collected it. If it was collected by a group of students, then perhaps the more people that get involved in collecting measurements, the more likelihood there's going to be of error. So think about that. Think about, was it collected accurately? Now, how do you know it was collected accurately? Just because your teacher collected it, they might have made the numbers up. They might have used a random number generator to come up with the numbers. So how do you know if it was accurate? How do you know how they collected that information? So that could be something that could lead to writing an observation. Think about website sources. Are they trustworthy? So if your teacher's pulled out information from the World Health Organization, well, that's considered to be a government source, which is considered to be fairly reliable, in which case you'd be saying, well, it's a trustworthy website, so chances are it's observed that you could say that their collection of data is accurate. Think about how it was measured. So if you're measuring, for example, arm lengths, some people might measure from the top of the fingers to the bottom of the elbow. Somebody else might measure from the base of the wrist to the bottom of the elbow. So this is where you could be making observations that there might have been errors. Think about the equipment that was used. If you're using a set of digital scales at home, maybe your baby brother's been jumping up and down on that and hasn't been accurate, hasn't been calibrated, and therefore the results might not be accurate. Or is it calibrated equipment that you know has definitely been checked recently and is accurate in its measurements? Think about the likelihoods there are. Where could mistakes be made? So this is something you could talk about in your observation. It is observed that mistakes could be made in the collection of data. One person may have measured it differently, or the scales may not have been calibrated. So that's something to consider. All right, some more tips. You need a minimum of 2. I've mentioned that already. Now you might be thinking, is the more the merrier? Well, the thing is that every observation you write needs to be justified, and I'm going to talk about how to do that in our next video. But let's say you wrote down 10 observations and 3 of them were justified, but 7 of them weren't. Now, what your teacher's going to be thinking is, on balance, have you justified your observations? Now, yes, you've got more than 2, so you definitely hit that part of the descriptor, but if they're not on balance all justified, then your teacher may decide, right, well, the majority of them are actually not justified. I can't give the top award for that. So it's not just about your teacher looking for 2, it's about your teacher on balance deciding, are most of these justified observations? So it's not necessarily a case of the more the merrier. It's a case of writing a handful of really good ones. Focus on writing 2 or 3 really good observations, writing them well, using a source to support them, justifying and giving reasons for why they would affect the results, and then you don't need to write 10. You've actually saved yourself space and time. I wouldn't recommend writing them as lists, like I talked about earlier, where I said such as other factors, such as blah, 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 blah. No, break those blah, blah, blahs into a blah, and a blah. Break them out so that they are individual observations, and then you get credit for them individually. This doesn't mean that you have to write them all in full sentences. They can be written as dot points, and we'll show you some different ways to present those in a moment. Now, remember, you need to reflect on those observations in your evaluation at the end of your PSMT. So this is once again a case for don't write 10, because if you write 10, you've got to then go and evaluate 10. That's a lot of work. Like I said, 3 really well-written observations will lead you to 3 really well-written assumptions, which will lead you to 3 really well-written evaluations of your observations and assumptions. So we don't want to overburden ourselves with too much work, and we don't want to affect our word count either. Okay, let's move on and talk about assumptions. I've touched on them briefly. The definition is that these are conditions that are stated to be true when you begin to solve the problem. Now, a lot of people find the idea of assumptions a little bit confusing. It comes from the word assume. So I say things like, I assume that the sun's going to come up tomorrow. I don't know if 100% for sure. I mean, history tells me that it probably will come up tomorrow, but there could be a cataclysmic event and the sun may not come up tomorrow. So it's an assumption because I don't have 100% confidence in it. So think about your observations that you made. Now, if we were doing the Pythagoras theorem example that we talked about, you've observed that to use the formula, you need an exact right angle. Now, in real life, are we going to find ground that's 100% flat? Are we going to find vertical structures that are 100% vertical, therefore making a perfect right angle? Probably not. So you're going to observe that you need a 90-degree angle to use the formula, and then you're going to assume that the formula is going to be applicable because you're assuming the ground is perfectly flat, assuming the wall is perfectly vertical. When you go to reflect on that later on, you may decide that on evaluation, they're probably not. So the idea of an assumption is you notice something that should be like this, you assume that it is like that, and then later on you talk about it probably wasn't like that. Okay, if we have, for example, we've observed an outlier. We've talked about it, we observe an outlier. It's an outlier because it's sitting away from the rest of the data, so you've given a reason for why it's an outlier. Now you could assume that that outlier, because it's a real measurement that you actually measured, you could be assuming that it's accurate, for starters, and it's not going to affect the results, and you could choose to leave it in your data set. On the flip side of that, you could assume that that outlier is inaccurate, that there's been an error, and that you're going to choose to leave it out of the data set. Whatever you choose here is going to have effect on results, but you're going to be making the assumption that it's not going to affect your results by removing or leaving the outlier in. So we've just seen that there. We might decide that that outlier is an error or it's not representative of the rest of the population in that scatter plot, and we may choose to remove it from the results. So we've got to assume it's not going to affect the results or assume that it's not reflective of the whole population. So you can see here an outlier can produce some great assumptions depending on what you decide to do with it. I often think it's a great idea if you've observed something to not have to think about separate, completely different assumptions. Link your observation and transform that into an assumption. We've talked a little bit about how to do that. But for example, if you've got a sample of teenagers who are still growing, you've observed that teenagers are still growing, and you've observed that that could affect the accuracy of your results if you're going to be extrapolating that out to the adult population. However, then you can then transform that observation into an assumption and say, it is assumed that this is not going to affect the results, or it's assumed that they will be representative of the population so that conclusions can be drawn about the whole population. So this is where your observation becomes an assumption. I would say if you're going to do it that way, keep them separate under separate subheadings and use that wording, observations and assumptions. You could observe that your sample was taken from an unknown source, and therefore it is uncertain whether this source has done the measurements accurately. There's your observation. Now you could assume that they were collected accurately so that you can rely on the results to come up with a conclusion for the report. So that observation that you know possibly has some error, now you're going to assume it has no error so that you can actually do your study. Here's some more tips on how to write those assumptions. Once again, you need a minimum of 2. And as with observations, don't overdo it and come up with hundreds of assumptions. Keep it simple because you're going to have to write about them again later in your report. They all need to be justified. So if you've got 2 written down, I assume the results are accurate. That's actually not justified. Why do you need to make that assumption? Okay, don't just write them as a list like I mentioned before. So you wouldn't be saying, I assume that diet, ethnicity and genetics won't have an effect on results. That would be taken as one assumption. Okay, so write them as separate assumptions as individual statements. And while you know, for the most part, your assumption's not going to be realistic, you can still make that assumption to do the report. And this is where I find students get a bit confused and they say, well, I know it's going to affect results. Why should I be assuming it's not going to affect the results? The whole point is that you need to make that assumption so you can then go and create an equation or create a model and make predictions using that. And then you need to reflect and evaluate on the fact that they probably weren't realistic later on. So it's okay to assume that things are accurate. It's okay to assume that they're realistic, even if you know that they're not. So here's an example. We know errors happen. Assumptions of 100% accuracy aren't always valid, but you need to start that mathematical process of assuming things are what they may not be so that you can come up with conclusions. I know that seems counterintuitive, but it's just the way this works. So that's where that evaluation becomes super critical at the end, where you're going to reflect that things probably weren't 100% accurate. Okay, let's talk now about how to set it up. Once again, I've mentioned this upcoming video several times. You've got to justify those observations and assumptions. So there's good ways you can set them up. This is going to be done in the initial part of severe assignment, what we call the formulate section. You don't necessarily need a formulate heading, but you should have a heading that says observations and assumptions, or an observations heading and an assumptions heading. It's a good idea to keep them separate so that you can mentally count off how many you have of each. You can write them in dot points or full sentences. Either is acceptable. Here's an example of a full sentence one. It is observed that rainfall evaporates quickly in hotter weather. Therefore, now this linking word therefore leads to your justification. You could also put this as a dot point. Assume the ground was completely flat because. So notice here I've used the word assumed and here I've used the word observed. It makes it super clear for your teacher which one you think it is, because your teacher thinks this is your observation. If you cut it off here and just start with the words rainfall evaporates quickly in hotter weather, it's unclear to the person marking whether you think this is an observation or whether you think it's an assumption. That leaves it then to your teacher's judgment to decide which one it is, and it may not be what you thought it was. So that may mean you are running short on assumptions later on or observations later on. So it's good to use this language here that makes it very clear to the teacher what category to put this under. So that's what I said here about using the phrasing. Don't leave them to guess. So I've observed and I've assumed. You can also set up observations and assumptions in a table. I actually had one of my students say to me yesterday, oh, I had no idea I could do that. It's actually a really good use of white space. Typically, if you're writing dot points, you might have a page this wide and you've got all your dot points coming up to here. So you've got all this wasted space, and we know that page count is critical. So this is why if you set it up in a table, you're going to use that white space more effectively, and instead of this running into half a page, it's now run into a quarter of a page. So notice here, I've got rainfalls higher in Rockhampton than Toowoomba, or teenagers haven't finished growing. There's my observations, and then I've got an assumption following out of that rainfall patterns will follow historical trends, or that trends for teenage heights can be applied to an adult population. Now the ... here simply means I haven't finished justifying it yet, and I would need to do that. Well, that's all we have in this video. Do stay tuned for that upcoming video where I'm going to get excited, as I usually do, about talking about justification. If you had any questions about what you saw in today's video, mcclutchymaths@yahoo.com is the best place to reach me. Putting it in the comments can be hard to do a good explanation. So if you want to put it in the comments, you might get 5 words back. But if you want to get a really good, thorough, justified explanation, email's the way to go. Well, thank you so much for watching. I'm Natalie McClutchy. Have a wonderful day.